Hello and welcome to Mellow Labs. As you all know, we've recently moved into a new place and that comes with a whole bunch of different things for me to do, but the thing I need to tackle today is making a doorbell because people have to knock on our door and that feels kind of cringe in this day and age, so I want to make a smart doorbell. When I started thinking about the project, the idea was quite simple. I get an ESP32, a push button, and every time the button is pushed, it sends a notification through Home Assistant to my phone telling me that I should check the door. But then I was like, it's kind of a waste of a whole ESP32 just to handle a single button push. What else can I add to the ESP32 that will make it a little more worthwhile? So I was like, well, I've got a letterbox, maybe I can add like a read switch or something so that it tells me when mail has been delivered. And then I was like, oh wait, we also have the power delivery stuff here. Maybe I can do power monitoring with the same ESP32. Now originally I did want to do measuring of each individual circuit so I know exactly where the power is going, but I think for now I'm just gonna hook up a current clamp to the main power into the house and then just, measure that. So that's the plan. A read switch, a push button, and a current clamp all on one ESP. Now, the biggest problem I'm going to have to solve here is power delivery, because the best form of power delivery I have available to me here is this light bulb. And I'm not messing with that circuit. Ironic because the fuse box is right here. I could just add another circuit and have an outlet here, but I'm not legally allowed to do that myself. So instead, I think I'm just going to use battery power. I'm going to have to recharge it every so often, but it beats running a wire from like the nearest socket, which is like over there, all the way along the wall and all the way up here. It's just not worth the pain. So yeah, right, let's get to work. JLCPCB. With 19 years of experience and 5 state-of-the-art factories, it's no wonder that over 5.4 million engineers across 180 plus countries rely on their reliable and affordable services. Getting started is easy. Simply upload your Gerber files, get an instant quote, and place your order within minutes. It's just that easy. Whether you're prototyping or producing in volume, JLCPCB offers unbeatable pricing with 1 to 8 layer PCBs starting from just $2. But it's not just affordability. JLCPCB delivers premium quality with lightning turnaround times. Your boards can be ready within as little as 24 hours. All thanks to their fully in-house production process, which ensures quality control at every stage. And right now, there's an exclusive offer where you can get 6-layer PCBs for just $5 with $30 off of your first order. If you're ready to take your electronic projects to the next level, visit JLCPCB. So for today's project, I want to use an ESP32C6. Now, it's an important distinction because the C6 is not yet supported by ESPHome. So we're going to be using Zigbee instead. Now, I've played around with Zigbee a little bit. I have this sort of Zigbee dongle that I got a while ago. I've only played around with buying like pre-made buttons and switches and stuff like that. I have not yet made my own end device to connect to Zigbee, so that's what we'll be playing around with today. I need a couple other things though. We're obviously going to need a nice big button for the doorbell. I have some of these. They're very satisfying to press. Every time I leave it on the desk, it just becomes a fidget toy, so that's a good sign. They also seem like relatively robust, so hopefully they last quite a while being exposed to the elements. We also need one of these reed switches, which are just magnet switches. And we're also going to need a current clamp. I have 2 available to my disposal. This one is 50 amps, which is not good enough. This one is 100 amps, which is the supply going into our house. So I'm going to use this one and save this one for a future project. This should be everything I need to get started. I'm probably going to need like a couple of resistors in places. Oh, also I'm going to need the battery, but let's try to make these individually work. Let's start with the button. This was so much easier than I expected. Like, not a single AI prompt was made. I set up the dongle in Home Assistant. I'm using Synology Virtual Machine Manager, so I had to like route it through there to tell it to detect USBs. And then Home Assistant was just like, oh cool, new device, mine. So then I plugged in my ESP32 into my computer, I set up Arduino, I selected which device I'm using, and then in the examples folder, there's a whole folder of like Zigbee examples, and I selected binary input because that's what I want to do. This is just a binary input, right? So I kind of read through here, and all it says is it must be set up as a Zigbee mode. So you go into tools, set it up as Zigbee mode, and then you go into partitions. I wasn't quite sure which partition to choose. I just selected the first one that had Zigbee in the name. I selected which pin I'm using. It also asked for an analog pin, but I didn't see that referenced anywhere in the code, so I just removed that line. Selected the pin I'm using, which is pin 6 in this case. Uploaded the code, enroll new device, and like here it is. All I have, like, press button, it turn on. Press button, it turn off. It's just, it was so easy. Right, I guess I would just connect the read switch to a different GPI open, see if I can get both of them to show up, and then we'll move on to getting the current clamp. So I modified the code a little bit. I've added a separate input for the read switch. I've also renamed, so this is now called the doorbell, this is called letterbox, and we should be ready to just upload, and fingers crossed it works. Upload failed. Why? Oh, because it's not plugged in. That would make it easier, wouldn't it? Right, do I now have to like reintroduce the device, or will it just pick up updates by itself? So I've screwed something up because I've deleted the device because the names weren't matching up, and now I can't get it to reconnect as a new device. I think Zigbee heard me being way too excited about how quickly it worked the first time, so it had to knock me down a couple pegs. So I went down a whole rabbit hole. I implemented a reset function in the script to like let me format the Zigbee client integration end device to reset the ESP so that it's like I'm ready to connect to a new bridge. Then I deleted it in here in Home Assistant. I then added it back, and eventually it worked. It took like 13 rounds of doing that before it like properly is like, I'm a new device and I have these two inputs, and it works. I did have to rename them because it calls them something else, because apparently renaming things isn't as easy on Zigbee as it is on ESPHome. But anyway, I got it working. So now I have doorbell, which is also a momentary switch now. Look at that, beautiful. And I have the magnetic switch for the letterbox, and that works too. Fantastic. Right, so now we just have to implement a current clamp. Okay, so I've got it working. It just took a long time to get here, long enough for the sun to go down and then come back up again. I had to make like a little voltage divider slash capacitor slash burden resistor circuit. It basically just maps the, you know what, no, I'm not doing this. I'm not gonna explain all of this because this deserves a whole video just by itself, and I'll probably do that when I get to like properly measuring the house energy usage stuff. So I will come back to this, but I now understand it more than I did before I started, which is good. I got it working. Zigbee is kind of, how do I say this? Annoying. I cannot get it to like properly set the analog input that this is. So in Home Assistant, it just thinks that this is a temperature sensor, because that's the only floating values that it can deal with. So I had to put it into Home Assistant as temperature, and then I have a Home Assistant configuration that maps it to current and watts, and then I have those as separate entities. Long story short, it works. Let me demonstrate. So this is my testing setup. I've got a whole bunch of things connected to an extension cord, which I did a naughty thing to, which you're not allowed to do at home. I will tell your mom, so that I can actually measure the current. That's all connected to here, blah, blah, blah. And I've got Home Assistant on my iPad telling me the amps and the watts. Now the watts are not accurate because I don't have a voltage measuring thing. So I've just set it to a hard 240 volts. So if voltage differs in the house, it won't adjust for that. So just know that going in. That said, I will be using the voltage as the main reference because it's kind of easy to, see what's going on. Plus all of these I know the wattage ratings for, so it's just easier for me to point at things. So let's turn on the popcorn maker and we'll see Okay, so that's about 1,200-ish watts, which is what the popcorn maker, which is what the popcorn maker claims to be. So that's somewhat accurate. I did try to calibrate it by using this very cheap Amazon current clamp. I have no idea if it's accurate, but it's accurate enough for me to somewhat know when how much power I'm using, so that's fine by me. Okay, let's try the kettle. The kettle is 3,000 watts, so that is about 2,600, so that's pretty good. Otherwise it would blow the 13 amp fuse that's actually in the kettle. Now this guy can pull, actually I don't know what the whole thing is, but we can just kind of turn it on and set it to max and see what happens, right? 2,000. That's it. These are in the wattage mode. So this should be pulling 1,000 watts. This should be pulling 1,200. But it's only pulling 2,000. That's a little disappointing. What if I click the boost? Ooh, there we go. That spiked it up. Okay, cool. I don't actually need that much water boiled. I'm waiting for the fans on this to stop whining. Good to know that the fans are using 270 watts. Okay, so I guess that just leaves me with going upstairs, making a nice little prototype PCB for this to hold it all together. And I still need to do the power issue. I think I'm just going to use an 18650 and just see how long it runs for, and then like maybe play around with some sleep settings and stuff like that. So let's go and do that. I finished putting together my little prototype PCB with all the components on it and everything, and I added a little voltage divider with just two resistors to read the battery voltage off of this 18650 that it's currently running on. And I still don't like Zigbee. It's just, I don't know what it is, it just doesn't quite work the way I need it to work. Like, I'm getting analog values from this, I'm getting amps and watts, and obviously I'm getting voltage from the battery. But for some reason in Home Assistant, those are all temperatures. Like, I changed the inside of the configuration file to take that source and just output it as an amp or watts, but I couldn't be bothered to do it for the battery, so the battery is currently at 4.08 degrees Celsius. I mostly just added it because I'm curious to see how long it takes for the battery to actually drain. Currently it's reporting the value, I think every 10 or so seconds, or when it changes. I'm just gonna I'm not gonna connect the doorbell or the thing to it yet, because I just want to see how long it lasts on the battery to see if it's, you know, something I'm gonna have to like change every day or like once a week. So I'm just gonna plug it into the mains and see how long it goes for. It's the next day. I only just removed this from the fuse box and it's still running. It's been, I think, 20 hours because I put it up at like 2 p.m. yesterday and it's almost 1. I'm surprised at how long it's run. Apparently the battery is now at 3.3 volts, which is not a safe voltage for these batteries, but like it's still running. I thought it was like dead because the LED on the ESP isn't blinking anymore, but if I short these, then it comes on. So it's still sending data and everything. What I'm going to do now is I'm going to charge this battery and implement a bunch of sleep, I guess. I've not looked into how to do sleep yet, so that's going to be a fun one, but hopefully it takes about as long as this battery takes to charge. So I'll come back to you when I've implemented some sleep and then run the test again and see how long it lasts then. Long story short, I gave up on Zigbee. That's all I have to say. It annoyed the crap out of me and didn't work properly. So instead, I found out that ESPHome actually now has support for ESP32C6. It's not great. There's a couple issues with ADCs, but I tried my best, even using the development branch, to get it to work. And eventually, I gave up and switched to using the ESP32C3 because it's just reliable. It just works, and that's all I ever needed. I just needed to work. So I'm gonna rerun my battery test on the C3 now. I think that's gonna be a little more power hungry. I don't have a good enough way of checking how much power it's actually using, so I'm just gonna plug in the battery and see how long it takes till the battery goes down to a level where it's no longer acceptable or safe to keep a 18650 battery. That's where I'm at. Luckily, the 18650 is now charged, so I can plug it in, not at the same time as that, and get it to work. And if it doesn't last as long, I'm hoping we can make it last about 12-ish hours. I think I have a way of getting this to perpetually power itself. Yes, free energy. Right, I'm gonna go and install this and then go to the store because it's been a long day and all I've done is just look at Zigbee and Arduino code, and I no longer like looking at Zigbee and Arduino code. I miss the days of MicroPython. It's been 19 hours and 50-ish minutes, and the battery is actually doing better than during the last test because it's only at 3.7 volts. So ESPHome is more efficient than Zigbee. I would take those results with a grain of salt because I'm pretty sure the batteries didn't even start at the same voltage level when I did the test, but it works. Like, it lasts for about 20-ish hours, which is pretty good. Now you might be thinking, why? Because that's not even a full day of battery power for an ESP. Yes, but I have a plan. In my box of many things that I've had for way too long, hoping for a project to come along, I had a solar panel, and I don't remember why I have it. All I know is that it works, and I checked that by putting it up to the sun and measuring the voltage with a multimeter, and it gave me about 5 volts depending on the sun. But I'm hoping that if I hook this up to the battery, it will charge the battery during the day, and then it can run on battery during the night, and it can kind of like balance itself out, right? That should work, hopefully. And in the winter months, when the sun doesn't show up in the UK, I can maybe just plug it in to charge it every couple days or so. We'll see how it goes. This is just a very long-term experiment. So I'm gonna hook this up. I've got like a little battery charger module that I've got it hooked up to the thing. I'm just gonna plug that into the battery and into the input of that, and kind of just hook it up and hope for the best, really. It's kind of my plan with all my projects. Okay, so keep in mind I know almost nothing about how solar panels work. Currently, there's a little bit of sun, but it's definitely above us, so none of it is hitting directly the solar panel that's in the window. We're getting 4.3 volts, but then on the battery on the battery input, I guess, going from the charger, we're getting 1.2. And then on the input of the ESP, we're getting nothing? 1.1. So I'm not sure why, but if I'm charging the battery and hopefully it works. We'll find out tomorrow. Welcome back. It has now been 7 days since I've installed this system in our electrical box to see how long the batteries can last whilst being supplemented with a solar panel. Here's our correspondent Thomas with the results. Hey, thank you so much. And as you can see, for the last week, we've only had to change the battery 4 separate times, and each time the battery lasted a little bit longer. On the first battery, we lasted for a whopping 20 hours, and then we had 27 on the second battery. On the third, 50 hours. That's incredible. And on the final battery, 57 hours. That's an incredible amount of time to run on a battery. We will get to the results of the solar panel later, but first we need to take a look at the battery health, because over time this kind of depletion is really unsafe. As you can see, on some of the longer days we are dipping below 3.7 volts, going to as low as 3.3 or 3.2 volts, which is incredibly not great for the battery. And this is because neither the battery charger or the ESP have a low voltage protection circuit which cuts the battery off when it gets to a low level. So it just keeps sucking everything that battery can give it until it just doesn't have any more. You really don't want to do this for an extended period of time. So now let's get to the solar panel. Now, unfortunately, we live in England, which means the sun very rarely actually shows its face, and we can kind of see on the graph the couple times that it did actually happen. right here, we have a nice little bump on Friday where the sun revealed itself for maybe an hour or maybe even half an hour and then just disappeared again, and the battery continued depleting. And we have an even slightly nicer graph on the last day where we have a nice little, you can see this curve that kind of elongates a little bit longer than the normal battery depletion graph. So we have a little extra sun right there, which really helped it get to that 57-hour mark. But unfortunately, this is not a sustainable life for the battery, and the solar panel really didn't add that much. Back to you, Tom. So you're probably wondering, where am I going with this project next? And honestly, I was kind of just gonna can it because that was the last idea I had. That was until I realized that the solution was kind of staring me directly in my face. This is the fuse box, and the cables from it go directly upwards. And you know what's up above this bit? This cupboard, which means that the closest socket is right here. So I can run a USB cable from here through the hole, down, and to the fuse box. However, we do have to move all of that stuff out the way. I have found the fuse box. So I had to drill a little hole, and just my luck, I've nailed the joist directly in the middle. If anything, I think that's a skill. But right down there, where you see that little bit of light, that's where the cables are coming in. So I feel like I can fish that with like a bit of a wire. Way! Only took 14 trips up and down the stairs. Now that that's all sorted, I can go and plug this in again. So with the power situation sorted, we can move on to the bits and bobs that attach to the door. So first of all, I modeled and printed this little thing to hold the button on the door. I had to make it quite thick because of the thickness of the button, but the button just sits in here and we can press it, and the wire is gonna go through the door. So I'm just gonna drill a hole all the way through and then run the wire through. And then for the letterbox, I've got a reed switch and this little contraption. A magnet's gonna go on there, that's gonna go on the letterbox, and then that's gonna move away and open the reed switch when the letterbox opens, which will send a notification to my phone. Speaking of the wire, I don't have wire that's long enough. Well, that's a lie, I do, it's just a little unconventional. I'm gonna use Cat 5e because who doesn't need a gigabit connection to their doorbell? I've got my doorbell, I've got my reed switch, and I've got my magnet on a stick, and a very inconvenient solid core wire. Let's go and install it. I forgot something. Hot glue gun. Okay, so that's gonna go here, and that's gonna go here. Glue. That seems pretty good. Okay, so now it's time for me to install the doorbell. The problem is I don't want you guys seeing, the outs. Oh, the wire just broke off. I'm gonna fix this and then I'm gonna install the doorbell. I don't have a particularly good way of keeping these wires in place. Actually connected the letterbox. I needed that. That's hooked up. Let's check if it works. I actually need my phone for that, so okay, so now that I'm done setting it up, I've tested both of the inputs, they both work. So now it's time for me to do the Home Assistant configuration. Starting on our dashboard, we're gonna go into settings, and then into automations and scenes, and then we're gonna create a new automation, and then create new automation, and then we're gonna select a target. So when our target, which is going to be an entity, and we're going to look for a state change, and we're gonna go doorbell, which ignore those two, it's just this one. And then we're going to go from off to being on. And then when that happens, we're going to click the button that's under here. It's called Add Action. It's right under the camera. And we're going to go Notification and Send Notification. And then here we can write this one says message. You can't see it because it's behind the camera. And this is going to be, and we can also add a title, which will just be perfect. And we can save that. Yep. And now that that's done, we can go up here and click Run Action, which should pop up a notification on my phone saying doorbell. Someone is at door. Yep, that's spelled correctly. And now we can also duplicate that right there. And then instead of this being the doorbell, we can do letterbox right there. And we're going to have to flip these because I can't be bothered to invert the input. So it goes from being on to being off. And we can change the name of the notification. And then we're going to click save, do that. And then we're going to click Run Action again just to test it, and we see we have a notification. Fantastic. So now when I press the doorbell, I get an almost instant notification telling me that there's someone at the door, and the same with the letterbox. Isn't that great? So with that, thank you very much for watching. Don't forget to like and subscribe. Support me on Patreon if you can. And yes, I did blue tack my iPad to the wall for this. I'll see you in the next episode. Welcome back.